Hello and welcome back to the channel. My name is Eddie Jennings from EJSLLC.com. This video is another in my practice session series for the Red Hat Certified Specialist and Linux Diagnostics and Troubleshooting Exam EX342. Before I dive in, I want to thank returning subscribers for watching another video, as well as invite anyone who's watching, if you haven't subscribed yet, to click that subscribe button. Also, a reminder that these are my practice sessions for the exam. My exam's just under a week away, and so I'm going through all of the posted objectives from Red Hat, and I'm trying to either explain the objective or do some examples of whatever the objective is talking about. And at the end of the video, I'll do a little self-assessment, and hopefully I'll feel confident with the objective. And if not, then I still have a few days left to do some final brushing up and getting some information back to the front side of my head. Since I am still learning myself, these should not be considered tutorials, nor should they be used as authoritative information. I try to have the information accurate, since hopefully at this point in my preparation I haven't learned something wrong, but because I am still learning, I do not advertise these as tutorials or recommend they be used as authoritative information. I am putting them out on the internet though, in hopes of those that are preparing, you might see some of the stuff that I do in a practice session, and it might give you some ideas of exercises to create for yourself, and might be of some help for you with your own preparation. But again, this should not be considered authoritative by any means. My voice is a little lacking today. The Athens Rock Lobsters, professional hockey team in Athens, Georgia, had their home opener last night, and of course I have to attend that, and some yelling occurred during that, so we'll see how well I can do with my practice sessions today. So we're continuing on in the diagnose application issues part of the objectives, and we're going to look at identify an application, or identify if an application suffers from memory leaks. So I don't have a super in-depth understanding of exactly how RAM works, or rather exactly how the Linux operating system manages RAM. Managing RAM is one of the key things that operating systems do. It's and I obviously understand how RAM works as far as, this is your volatile memory that basically all your applications and such are loaded in, and is what is manipulated all the time. Sometimes it is written to disk, other times it is not. And from what I understand, the way memory works or the way the Linux operating system deals with memory as far as what it presents to applications, you kind of have two layers. You have the physical memory, which that is literally what's on the stick of RAM in your DIMM modules, what's actually available. Before I go on, we'll go into lab server 1, because there will be a couple of things I want to look at while I try to expand upon this. And I believe the physical memory is sometimes referred to as reserved memory, if I recall that. I think there is it the proc file system? Yes, I want to see all the, yeah, of course, that's going to be everything. Where is this at? I think it's the run file system. Oh, mem info. Let's just go into proc mem. Let's go into the proc file system. Then we want sys, or is this what we want? Let me cat mem info. Maybe this has what I'm wanting. Ah, yeah, this is what I was looking for. There's all sorts of information here. I thought there was, is it committed? Perhaps this will be something that I do want to review again. But basically, you have the actual physical memory, but what the Linux operating system is presenting to applications is virtual memory that is a layer on top of the physical memory. And I may be explaining this poorly, and I encourage you, since I obviously said this should not be considered authoritative information, and this is why. If you are a master of memory, by all means, correct me in the comments so those that are watching this can get accurate information. But the virtual abstraction of memory is what the operating system is actually allocating to applications. It's obviously taking account of the physical memory, but it is the virtual memory that is really what's being consumed. And this idea of a memory leak is applications using the memory. It's asking the operating system, hey, give me memory to do what I need to do. And what an application should do is, when it's done, it basically hands that memory back to the operating system to, give to another application or whatever. A leak is when that doesn't happen. And so a virtual memory leak is not the end of the world, but it's obviously not good. But if the memory leak is involved with the actual physical allocation of the memory, that's where you can really get into problems of an out of memory situation, which will basically crash your system. Now there's a OOMD process, out of memory management, I think is the name of it, that will try to kill applications to keep the system to be stable. But generally, if you're getting into that condition, there's a problem. So the question is, how do we identify this? And I'm fairly sure what Red Hat is intending for this. I mean, you can use something like free, show you your available memory. Used, I believe, refers to the actual physical memory. Top can show you some about memory. And what is it? This is what I was looking for. All right, well, what I was thinking of before. You obviously can't hear what I'm thinking, but this resident memory is the actual physical consumption, and the vert, I think this is in bytes, and the vert is that like virtual abstraction layer that the operating system is actually handing to your application. So you can use that. You can also get memory stats from SAR, but for kind of testing real time, there's something called Valgrind, which in my training for this exam, this was something I had never used and still have it used in production, but the idea behind it is pretty nifty. So I'm going to install, pretty sure just Valgrind is what I need to install for this. And apparently this is a framework of several different tools, one of which helps identify memory leaks. You'll see Valgrind is going to install a bunch of Perl stuff as well. If I were to man into Valgrind, no man entry for Valgrind. Oh, Valgrind, yeah. There's not going to be a man entry for Valgrind. But for Valgrind, memcheck is the tool that we're going to be using, but there are all sorts of different little tools with this. I have only done a little bit of practice with memcheck just because of the objective focusing on memory leaks. But if you are an application developer, or if you're, well, I guess, yeah, you'd still be an application developer, but if you're really wanting to figure out exactly what's going on with various aspects of your application, this tool can help a lot. So in my training and such, the training materials had some applications that were like designed to cause memory leaks. And so, you ran your little Valgrind thing against that application and confirmed if there is memory leaking. But we're going to try to do this against a normal application and just see what happens. So I wonder how effectively I can do this. So what I want to do, Valgrind, and the tool I want to use is memcheck. And of course I'm trying to do this from memory. And let's do that. Let's see what happens with top. It's running top. Yeah, do Q. Okay. So for the few seconds that I ran top, talks about the allocation of memory and such, and the suspected leak summary. It is not suspecting that top is leaking any memory, which I fully expected that. Let's do, we can play with DD for a bit. And let's do, actually, first of all, let me look at what I have available on my file system. All right, so I still have 40 gigs or so of root file system available. So let's see how well this works. So we're going to do Valgrind, tool, memcheck, and then the command I want to do, I'm going to do DD, the file, we're just going to do, dev urandom, OF will be test file, we'll do 4 megabytes, we'll do 1,000, and let's see what happens, if this will work. Shouldn't take too long to make this. I guess what I can do while this is running, we can go back into lab server 1. There's our test file. It's up to 3.6 gigs. Okay, so this was showing possible memory leak that could be occurring. So we're going to do this with leak check full as it says and see what other information that it gives us. Now, one thing to keep in mind, I don't believe on the exam we're going to have to fix the memory leak. You know, I have a feeling that it will be, well, I mean, obviously I don't know, even if I did, I couldn't tell you. I'm thinking identify an application if an application suffers from memory leaks. It might be one of these, we have to find the application. We will be using, or probably, I would imagine, use top to see if there's like a background running process that's chewing up a bunch of memory, and then run it with, stop the process, run the process again with Valgrind, let it do its thing. And then either like uninstall the application or reinstall it with the new, or upgrade it to the new version and it won't have the memory leak. Or maybe we have to fill out some type of text file and put the name of the package that has the memory leak. That's my guess with that. Or we might not do anything on the exam with it. I mean, sometimes not everything on the list is actually a part of the exam. But again, these exams are really more designed to prepare you for real life, not necessarily to pass an exam. And this is kind of a good thing to have available to you. All right, so let's clear my screen. And we're going to do, was that leak check full? Yeah, do test file 2. Let's see if it gives us some more information this time. One other thing to keep in mind is, depending on the application, it might need to run for a while before it's going to leak enough memory for this to be noticed, which is another reason why I'm not 100% sure this might truly make it onto the exam, because I think we have 4 hours for the exam. So I imagine the exam writers kind of take into account, what can actually be learned. So possibly lost, what would that be? 4 gigs in a block, maybe. This will be a tool that between now and the exam, I'll go back to my training and do some of the examples of. And of course, I'm not, expecting the applications here to really have problems. Take a look at one other thing in the Valgrind. Man pages for Valgrind. Something else I was looking for. This is one thing. This can be useful, looking at child processes that are spawned from whatever it is you were initially checking with Valgrind. I wanted to look at was the mem check section. So there was the leak check. Thought there was something interesting I saw in here before. I guess not. So for this objective, I'm going to consider it kind of a half pass. I'm aware of the application framework that is intended on being used for this, which is Valgrind. I'll want to go back and refresh myself on some of the use cases from some of my own training materials, but to just generate a basic report, which that might be something we have to do on the exams, like, generate a report on this application of whether or not it is leaking memory. Well, you run the tool and thus you have the output. That might be what it would be looking for. I'm not too terribly worried about this, but it is worth doing a bit more review. So if you found this video useful at all, make sure you do click like. I want to thank returning subscribers for watching another video, as well as invite anyone who's watching, if you haven't subscribed, do click the subscribe button and ring the bell when you do, so you're aware of when new content comes available. Thank you for taking the time to watch, and I'll see you the next time.